Hello, everyone. Can you hear me?
Yes, sir.
Hi, Tarandeep, and hi, Shanzita. Uh, Am I pronouncing your name correctly? Hello, hi. Yeah, we can hear you a little bit. All right. Well, welcome both of you. Thank you for joining the Drasi office hours. Let me share my screen and let me know if you're able to see the screen.
Yes,
Great.
it's visible.
Okay, great. Well, thank you for your interest in Drasi and thank you for joining the office hours. Yeah, maybe can you like tell me where you both are joining in from?
Yes, I am from India and
Okay,
I just wake up morning.
right. Must be like what, 7:30 a.m.
Yes, it's 7:30.
Oh, cool. And how about you? Your audio is kind of not
But
clear. It's kind of breaking.
it's very low.
Oh, maybe they dropped and they might join back again.
Yes, might be they have an internet issue or something. I will
Could be, yeah.
check.
Yeah.
Uh, Sir, on the Discord first message, there is like where we have timeline. In one timeline, we have May 25 and either we have MAR 25. So there is some confusion. Oh, that's
Okay.
why I think might be March 25. So that's why I ask.
Okay. Yeah, let me take a look at that.
Discord first message in GSOC.
Right. So, okay, here it says this one is fine. Oh, this one. Okay. Got it.
Yes.
Sorry about that.
No, it's just just after under the
Yeah,
accepted.
thank you for finding that. And
Welcome, sir.
okay, so there's a message on Discord.
Yes, sir.
There.
Uh, can you hear me now?
Much better, yeah.
Oh, I'm so sorry. I was just like out of connection for some time. I'm so sorry for that.
No, no worries. So, am I pronouncing your name correct? Shanzita?
Yeah, I'm Shinzita.
Okay. So, where are you dialing in from?
Oh, I'm from Houston, Texas.
Okay, great. So, pretty close by. So, I'm also dialing in from Seattle area in the US.
Oh, I see. That's cool.
Cool. So, it might be quite late. You're in the central time zone, right?
Yeah, it's 9:10 right now
Okay.
p.m. Yeah.
Okay. So yeah, I was just giving us some time if more people want to join, but yeah, let's get started. And we'll anyways record this for anybody else who may want to listen in later. If the time doesn't work for their time zone, so I'll just record this. And if you any of you have any objections, please let me know.
Okay.
I don't have any issues.
Okay. All right. So yeah, let's get started. Well, I'm just gonna give you like a brief overview of the project itself, and maybe we can talk about the different repos. So just trying to set some context, right? Because we have like a bunch of different people joining in the project, and want everybody to be aware of like what are the different repos and what the project is all about. So let's get started with that. So here's what I'm planning to cover today. So we'll just go over like what is Drasi, what is the team behind it, what is the project history, what are the different form factors, and I'll try to maybe cover the different repos that are available in Drasi project today, and then go over how it all fits together. Then maybe talk a bit about the documents, the tutorials, and what's coming up next. And then we can also talk about like we'll have some time at the end also for Q&A. And if you have questions in between, like as we are going through the slides, you can always unmute yourself and then describe, like you can always raise your hand or just unmute yourself and present your question.
Okay. Sure.
Okay.
Yes.
Okay. All right. So let's move ahead. So let's start with like what is Drasi and why does it exist? Like I'm not sure if you guys have had a chance to take a look at like the tutorials or any of the
Yes.
videos.
Run through tutorial. I
Yeah,
have a run through tutorial actually. The tutorial you
yeah. I also
suggested.
sorry.
Yes.
No, no, you go ahead.
Okay. The tutorial you suggested is really helpful. Like the visualizations help me quite a lot to understand how this works.
Okay.
Yeah, I also checked out the links you provided and like the tutorials and like how it's like connecting database and also updating and like how you're like comparing it with RAG and like how
Mhm.
you're coming up with the better systems. Yeah, I took a look at it and I also tried it out. Like yeah, it was really fun. And I also checked out the GitHub a bit. And also you yeah, I also took a look at the systems like very high level.
Okay. Yeah. All right. So let's try to like do a quick refresher for that. So this is like the core problem that Drasi is trying to solve, right? So we have data that is sitting in multiple different systems, right? So this could be different databases, it could be APIs, it could be config stores, maybe some blob storage. Some of the data is in, let's say, Kubernetes, right? So not sure how much experience you guys have with Kubernetes, but basically it's like a cluster manager, right? On which you have different nodes, services that are constantly coming up and going down, etc., right?
Yes.
And they're basically balanced between different nodes, etc. So now uh, there's some echo. Can you guys like both mute your mic while I'm speaking, and then when you have a question, you can unmute because I'm like having some echo. Okay. Okay, so yeah, so we have like different data stores, right? And then often what happens is like you want to detect some condition across different data stores and then react to that in near real time, right? So for example, think of the RAG demo that you may have seen in the KubeCon presentation. So there, let's say you have some database that is hosting products information. Let's say Postgres database have products information, and maybe another different service is handling the reviews, right? So people keep adding reviews for the products, and maybe that service is another microservice which has its own database, which is, let's say, a different one. Let's say it's MySQL database. Now, what if you wanted to build a materialized view that contains information from both of them, right? And then you would want that view to be up to date in near real time. Anytime somebody adds a new review, somebody updates the product information, all of that should be updated in the final derived view that you're trying to create. And that derived view could be anything, right? So it could be either a vector store used for RAG. It could also be another kind of composite API. So it really depends. So how do we build this kind of system today, right? So let's start with the first one, which is just a simple polling-based approach, right? So one way could be to just query like the different systems on a timer, right? So let's say you every 5 minutes you just run the queries on both of the databases. Or let's say if you have if you're trying to join information coming in from Kubernetes, maybe you just do kubectl get pods every 5 seconds, right? So you basically you're getting that information after a fixed interval. Now that is straightforward. It's easy to understand. But the issue is that let's say you are querying 10 times per minute, right? Or 10 times per hour. Now, maybe the data is not changing as frequently. So what we are doing is we are basically increasing the load on the system because we are repeatedly querying, even though nothing has really changed there, right? So we are repeatedly querying, and each query is basically taking some time or some resources from the system. The other end of it is like, let's say you reduce the frequency of polling. The problem then occurs is that the latency really increases, right? Because let's say your data change might have happened at 10 a.m., but because your polling frequency is, let's say, 2 hours, you may only react by 12 p.m. So it's basically 2 hour delay in your reaction to the changes. The second approach you could think of is event streams. So now this is basically from the big data world, right? So in big data, you have previously we had like batch processing in, let's say, the late 2000s or maybe around 2010. Batch processing had its moment where people were using MapReduce, Hadoop, and all of that, where you do like a giant batch of processing at one go. But then later, a lot of people came up with new systems, especially built on top of Kafka, using, let's say, Kafka Streams, Flink, etc. So these are basically stream processing solutions where the latency is much lower, but then you have to write all of the filtering logic, and you have to basically do state management. Because think of, let's say, you are trying to calculate the average review statistics, right? So let's say whenever a new review comes in, you need to know what was the previous average and what was the previous total count, right? And then basically you have to compute the new values. So whenever the new event is coming in, you need to maintain that state while processing this new event. So that's also kind of challenging. And if you go to our website on the curbside pickup tutorial, we've tried to show like how complicated the code can become if you're using stream processing solution. For the same example that we can simplify with Drasi. So Drasi is basically trying to provide a change-driven approach, right? So what we are asking is that people just need to declare what conditions or what results that matters to them, or what is the thing that they're trying to monitor, right? And then based on that, whenever the results that's actually change, Drasi allows you to do some kind of reaction. Now, this reaction could be anything, right? So it could be sending a Slack message, it could be updating a derived view, it could be anything really. And within Drasi, there's like three different core concepts. The first is sources, second is continuous queries, the third is reactions. So let's start with sources, right? So sources effectively are, you can think of them like input connectors. And this helps Drasi to connect to any kind of system that you may have. So let's say you have a Postgres database, you have a Kubernetes cluster, you have another microservice with its own APIs. So this goal of sources is to provide some kind of mechanism for Drasi to follow the changes that are happening on that system, right? So that's what Drasi uses to monitor that system. And the additional goal that sources do have is that they translate the data into a graph format. So because why we picked a graph format is because we want to support a multiple or a multitude of different systems, right? So let's say we want to support Postgres. So that is relational in nature, which is basically tabular data, right? So you have tables inside Postgres. Now think of another database, let's say MongoDB, which is document oriented. So there's like multiple different documents there. Now there might be other databases which are graph based, or maybe we are also want to monitor object store, which is just a set of files. So how do we like allow people to get all of that information together in one place and then define their condition on it, right? So that's why we are using this graph-based approach, so that each source will deal with the system that it's connecting to and then translate it into a unified graph format. Now, once all of that inside Drasi's indexes, that's where comes in the second concept called queries, right? And the reason why we call them continuous queries is they give you a perception that they are basically run perpetually, in the sense that they are processing all of the changes that are happening in your data, but it's not like we are continuously, repeatedly running the SQL query or something, right? So let's say we are connecting Drasi to your Postgres or any kind of relational database, right? SQL Server, Postgres, Oracle, whatever. So when we say query, people think of SQL query, right? So you are running the query once and then you just get a result set based on how the data looked at that point in time. But the Drasi queries are not like that. So you're not repeatedly running the queries because, okay, so let's roll back a little bit. let's say I want to monitor a table inside a relational database, right? So Postgres, SQL Server, whatever. I will write my query select star from table products and then maybe some other where condition, right? And then I will have to keep on pressing the refresh button to see if anything is changing, right? So that's how typically if somebody wants to follow changes, that's how they will run the query. But Drasi queries are a bit different. They would basically, what they do is they follow the change feeds of these systems. So a lot of these databases have something called a replication log or a change feed that is available. That's basically a delta stream, and that was not created specifically for Drasi. That these databases have this capability already because they kind of support replication options, right? So let's say you want to back up your data into a separate instance. So you have one database here and you have a copy here. Maybe you have one database running in West US, and then you have another one sitting in East US just for a backup in case some disaster or internet connection issues happen on the West side, right? So how do you keep them in sync? So that's why this change feed mechanism exists in a lot of databases. So that's what Drasi is relying on. Any questions so far?
Please
Okay.
continue.
Okay. Oh, yeah, you have a question, Shanzita?
Yeah, I understand the entire graph-based mechanism, but I'm like kind of like not sure how you're like handling the overrides because like for example if you're like pulling data from like Postgres and also MySQL, you have like the both CDC have like different independence. So like what if they both like try to like update on the same time, like how you're dealing the like do you have like any concurrency mechanism to deal with the override, like so that like it doesn't crash or like it does crash, like how do you deal it?
Right. So, let's talk about the overwrite, right? So when maybe we can go into the details a little bit. So let me just open the website for a minute, and let's take a look at Drasi for Kubernetes, and let's take a look at the one of these tutorials, right? If you have gone through it, that's great. But if
Yeah.
you have not, maybe after the video, you can after our call, you can take a look at it. But basically here we have two databases, right? So one is retail operations, the other is physical operations. Now, if we look at the config, so this is the simple YAML file, right? That tells Drasi about the data source that we want to monitor. So here, what are we doing? Basically, we are saying that we are telling Drasi that, hey, you should be monitoring a Postgres type of database, and specifically, you should look at the orders table within that. Now, it's telling about the database name and the orders table. And the way this particular source is written is what it does is it basically takes a look at this table. And for each row in this table, it will create kind of like a node inside Drasi's internal graph-based indexes. Since internally Drasi has its own indexes, which are graph-based. So there we need to create representation of any kind of data in graph format, which is nodes and edges, right? So we basically create a property graph there. Now, to come to your question, what happens? Let's say if somebody configures another source, which could be Postgres, which could be MySQL, but then it let's say have the same table name, right? So that's the one of the concerns here. So that's I think that's a key thing that you've figured out. So that will basically lead to an issue. So if the IDs and if all of the data is exactly the same, so then there will be a collision. Yes.
See. So I have like a follow-up question on that. If there's any crash on like a source pod, so like is there any like any lost changes? Like does it like lost the entire like whatever it has in their like memory? Or like how do you deal with like any like changes that's lost?
Yeah. So internally, what we do is like between sort at least in so there's different forms of Drasi which I was going to come to, but since you already looked at a bunch of stuff, so let me just go there. Okay, so within Drasi, right, I don't have a diagram here, but within Drasi, the source, the pipe between the source and the query engine itself, right? So that is effectively a Redis stream. The Redis stream is basically like Kafka, right? So and it's persistent. So until the query engine consumes that change, it will never be lost. So that's how the persistent story exists today in the Drasi for Kubernetes version. But there's other Drasi versions as well, like the Drasi server and lib, where this story is still not complete. So that's those are the two new modes that we are working on.
Oh, I see. Yeah, it's kind of like a caching system, like according to my understanding. Yeah, I think I will take a look at like more of the system side. But thank you so much for answering though.
Yeah, no, that's a great question. And basically, you can think of it as like a cache, but you can also think of it like a stateful stream processing engine, right? So what we are doing is basically we're abstracting away the stream processing capabilities so that people don't need to worry about, like if I don't know if you've written stream processing code before, but let's take a look here, right? So here I'm comparing how you would do this with stream processing, right? So basically you could take the orders database and vehicles database, push all of the events from the CDC events into the message broker, which could be like Kafka. And then you would have to write the stream processing job. Now this job needs to take care of like the windows, temporal joins, watermarks, etc. Like how long should it wait for an event to come from one to match it to the other, right? So all of that is kind of taken care of by Drasi internally. So that's what is the unique capability that Drasi is offering.
Yeah, and I also like another follow-up question on that. Do like I kind of go through the like entire systems like how you're connecting, but I have like one low-level question. Is it like does like Drasi cache any question or like is there any caching system already implemented? Because I'm like not sure like how that mechanism is working, or like it's just like very like a real time.
Yeah, so internally, Drasi builds its indexes. Let me just try to bring that diagram up. But Drasi does build its own indexes. So for whenever you write a query, right, whenever you deploy a continuous query, Drasi will build its indexes. Now the indexes could be in different pluggable modes, right? So we have options between three types of indexes. One could be in memory, the other could be RocksDB, third could be Redis or Garnet.
Oh, I see.
So
Mm.
each query, so when a query first time starts, right? So what it does is it does a bootstrap. So it gets the initial state from whatever sources it subscribes to. Let's say if there are two sources, it'll go into bootstrap, it'll get the initial state of the data. So it'll basically get the initial rows in the table, initial documents in the collection or whatever, build its so indexes, and thereafter it'll just follow the change tree. So basically the
Oh,
model is take a snapshot and then thereafter follow the change tree.
oh, I see. Yeah, now that makes sense. Okay, thank you.
Yeah. And I'll try to bring up the diagram with that as well. Yeah, so some of them might be in some repo somewhere. I'll try to find that later as well. But for now, we can take a look at this. So this is roughly how the internals of Drasi look like, right? So this is, let's say, the external system that we are following, right? So this could be the source database, could be graph, relational, or whatever, right? And this is the source, and it has like a bunch of different components like the reactivator, the proxy, change router, etc. And between the source and the query container, right? So this is where this is the change queue. This is the Redis kind of thing, a Redis stream, and it has a cursor in it. So this is why whenever the source gets some change event from the external CDC system, it will push it into this change queue. And thereafter, even if the system crashes, this is always persisted in this change queue until the query host is able to process that successfully and advance the cursor. Does that make sense?
Yeah, yeah, yeah.
And then internally, these are the kind of indexes, right? So let's say it has a element index, it has accumulator index. For example, if your query has averages or sums or some kind of aggregate functions, right? So that will go into the accumulator index. But all of these indexes are maintained in different systems, right? It could be either in memory, which means that you don't have any persistence or crash recovery story. But if you do want that, then you can use Redis or Garnet or RocksDB, etc.
Yeah, I see. So, like, is it like every time like the query is just like rebuilt from scratch, on like every time it restarts?
Every time it restarts. Oh, sorry, what was the question again?
Is it like every time like every question or like query has like its own result, and like every time is if it's like restarts, like does that question also rebuilds on the system, or like
Right.
it's
So
like
yeah, so
yeah.
if you are using a persistent index, let's say you are using RocksDB, right? I think the default is RocksDB in the Kubernetes version of Drasi. I think the default is RocksDB. So
Oh,
the query already has built its indexes in the previous, like the first time it started, it went in the bootstrap and took the snapshot and maybe processed some of these stream events as well, right? So it may have the
yeah.
initial state already, and it may have processed some of the events already. So its
Mhm.
indexes, let's say, are up to date up till event number 103, right? So
Mhm.
once it restarts, it will basically start processing from there, that point onwards.
Oh, I see. Okay.
So it basically resumes. So you don't need to boot and go through the entire bootstrap process once again. The
I
only case
see.
where it would need to do the bootstrap again is, let's say, uh, there's like a bunch of diagrams. I'm trying to find the latest one.
Mhm.
Uh, but effectively, you can think of if this change key was lost, right? So let's say the cursor here was lost. So then
Yeah.
basically the query needs to go to the bootstrap phase again because it needs to build its initial snapshot again. Or what if this Redis or RocksDB got corrupted? In those cases only, you need to do the bootstrap again.
I see. Oh.
Or maybe if you're using the in-memory index, so then clearly you need to
Mhm.
do the bootstrap again, right? Because your process crashed and
Yeah,
nothing was on disk.
I see.
Okay. Are we good to move on?
Yeah. Yeah.
Okay.
Thank you.
No worries. Okay. So yeah, so then these are the three concepts, right? So it looks like you, Tharandeep, are you good with these three concepts? We can move on.
Yes.
Okay. So yeah, like reactions are basically output connectors, right? So these allow you to basically connect into any kind of external system. You could be configuring a webhook, you can write to a database, you can log it, trigger an alert, whatever you need, right? But
Yeah.
just remember that the core query engine maintains a live result set, and it is processing diffs that are coming in, and it is also outputting diffs, right? So it's basically telling that, hey, from my result list of results, which is basically, let's say, you can imagine it like rows, right? So let's say it had 10 rows in its result set. Let's say an 11th one got added because of the conditions that changed, right? So it'll say, okay, a new entry got added, or let's say an existing one got updated, or a previous one got removed. So those are the three kind of events that Drasi queries emit. And then reactions basically take action on that. Okay. So these are the two patterns that I also talked about in my KubeCon talk, right? So these are like just two examples of how Drasi could be used. So because reactions can do any kind of action in external system, one of the actions could be to update a derived view, right? So it could be updating a vector store, it could be updating a live dashboard, it could be a CQRS model. So that is one pattern, updating derived views. The other one is just taking real-time actions, right? So let's say you detect a vulnerable image deployed to your Kubernetes cluster and you want to take some action, maybe send a Slack message to the appropriate team. Maybe you want to send an email or maybe launch a new workflow that basically remediates that problem. So all of those things can be done through Drasi. So basically, it's trying to make things simple. You just write your graph query, point it at your sources, attach a reaction, and Drasi will handle the rest. So let me just quickly give some of the team history as well. So we are just a small team of 5 people, and we sit within a team called Azure Incubations team. And this is part of the office of the CTO of Microsoft Azure. And it's the same team where another CNCF project has graduated from. So the other project that initiated in this particular team was called Dapper. And if you've looked at the GSOC project, that's where the collaboration also is. So the project involves both Dapper as well as Drasi. But even though it's backed by Microsoft, the project itself is fully open source and it's part of CNCF, Apache 2.0 license. So there's nothing proprietary here. And here's the timeline. Like we open sourced like our project in October of 24. January last year is when we got added to CNCF, and November last year is when we first went to our first KubeCon. And recently we launched like the other two form factors as well. And this year we are participating in different programs, like in the term one in February or so, we participated in Linux Foundation mentorship program, and we are also trying to participate in GSOC this year. Now I mentioned there's like three form factors, so let me just clarify that a little bit. So the one that most of the tutorials on the website point to, and what we have been looking at is the platform version. And this is the one that I also showcased until last year, because this is the one that we have been working on for the majority of our time. So this is basically a fully scalable version. It has a bunch of different microservices, like sources run as independent pods, reactions run as independent pods, query engine runs as an independent pod. Everything runs on Kubernetes, right? And it is best for like production systems if you want to run things at scale, and it has a bunch of different connectors, both on the source and the reaction side. Now, the other two are a bit different. So what we did was we took the core engine of Drasi, and and that is basically the delta or the differential engine, right? So that's written completely in Rust, and that's the Drasi core repo on our project. So this is the repo. Now, what we did was we took that and we made the concepts of sources, reactions, etc., also available there at the library level. So that if you want to, let's say if you're writing a Rust program for IoT scenarios, you don't want to deal with Kubernetes and you don't want to deal with all of that stuff. So you can include all of the concepts of like the input connectors, output connectors, and all of the indexing capabilities, etc., into the same single process. So that's where we have added this thing called Drasi lib, which is basically an embeddable library. And this lives inside the same repo as the Drasi core engine. So the repo name would be Drasi core itself, and I'll show that later. So this is the repo right here. So this is the repo, right? So this has the main Delta engine, and this is also used inside the Kubernetes version, but there we don't use the Drasi lib. We just use the differential engine, and we have basically built different microservices for sources, queries, and reactions there. And this has its own management plane and all of that. Now, the Drasi server itself is basically a thin wrapper around Drasi library. So because this is a Rust library, you need to be using Rust, and you need to write your own program to use this, right? So what we did was we wrote a simple shell program, like a simple wrapper program around this library. So this is the second kind of modality that is available outside of the Drasi lib and Kubernetes. So these two will continue to progress in the same direction, in the sense that they will always have parity between the a number of sources or types of sources and reactions that will exist. Because the simple reason, right? Because Drasi server is effectively just a wrapper around the same library. So whatever we add here will also show up here. And this is already the like the different platform that we have been working on for a while. So let's move on further. So where should you start? So this slide, because of the like compressed timeline, in case you're looking for GSOC, you may have less time, but process server is easier to experiment with locally, is what we have found. You just run the process. And the Kubernetes one is slightly tricky. But what we have done is like all of the tutorials on the website for Drasi for Kubernetes, what they do is like if you run them inside GitHub code spaces, right? So what they do is they effectively create the Kubernetes cluster inside that code space for you. So basically, we just use a kind cluster or a K3D cluster, which is like a minified version of Kubernetes to be able to run inside a container. So that makes things easy for you. So that is available, but this is like the general guideline. If you have more time, what we recommend here is that you start with Drasi server, because it's a simple process, right? You just run the Drasi dash server on your CLI, and it just launches using your config, and then you can experiment with it locally and then decide if you want to scale, you can use Kubernetes version. But yeah, you can play with both and then figure out whichever is easier for you. If you think Kubernetes is easier for you, you can use that. If you think Drasi server is easy for you to begin with, you can start there, and then later on you can decide whichever you want to use. Since the GSOC project involves Dapper, I think the Kubernetes one might be easier later, especially if you're trying to run both Dapper as well as Drasi, right? Because Dapper itself also runs on top of Kubernetes. All right, so yeah, I think this is as I said, Drasi core is the main differential engine, right? So this it's basically just the graph query engine, which takes a source change, applies some middleware, and it has like a path solver, evaluates the results, and just emits the result if. So we don't need to go too deep into this, but just know that this is the core Rust crate that lives inside the Drasi project and Drasi core repo and inside the core folder. The second one is Drasi lib. So this is what I was talking about earlier, right? So this is just adding the concepts of sources and reactions and bunch of different lifecycle management stuff, bootstrap provider, etc., uh, inside the Drasi core itself. So this is basically making the library fully usable as it is, right? So you don't need to go to the Drasi server or Kubernetes in case you are just working in a resource constrained environment, let's say an IoT example, right? You just want your single binary to have this capability, you can just use the library. And then from this, we basically publish a lot of Rust crates. So you can just use cargo add Drasi lib to start using this. Now, within this, we have the pluggable ecosystem like sources, reactions, bootstrappers, index backends. This is the kind of answering your question, right, from earlier. Where does Drasi stores its, where do the queries store their results? Basically, it can live in the index backend selected by you. So it could be in memory, it could be RocksDB, it could be Garnet. Here it says in memory as default because this is, I'm talking here about the Drasi lib or Drasi server. But for the platform, the default is RocksDB. And then this is the Drasi server. As I said, it's a thin wrapper around Drasi library, just adds REST API and YAML-based configs that allows you to basically control like start or stop sources, start or stop queries, reactions, etc. If you do want to do that management. It also has like CLI commands, and we are publishing the Docker image on our GitHub container registry, so you can just use it from there. This is how like this server config looks like. It's a single process. You just tell in a single YAML that the kinds of sources you want, the kind of queries you want, the reactions you want. So this is where like you might run into some issues because we are still a pretty new project, right? And the Drasi server and library are something that we are actively working on. Uh, and their YAML structure might differ slightly from what we have in the Kubernetes version. So just be aware of that and be mindful of those differences. So that's something that I would want to point out to you. But yeah, mostly, at least at the high level, the concepts remain the same. So this is the main one, the Drasi for Kubernetes, and this has the most number of sources and reactions and SDKs as well, right? So here you can use, you're not limited to Rust. So while I was talking about Drasi lib and Drasi server, I forgot to mention that that's completely in Rust. But if you look at Drasi for Kubernetes, here what we have done is like we have allowed people to build their sources, the input connectors, and the reactions, which is the output connectors, in multiple different languages. So we have added like SDKs in .NET, for Java, Rust, just as an example. So people can build sources using these languages, and people can also use reactions using these languages, like JavaScript, Python, .NET, etc. And there's like nobody stopping you from building another SDK, for example. Let's say you want to build a JavaScript SDK to build a new source. You can always go ahead and do that. And the Kubernetes version comes with its own CLI, so you need to run these commands like Drasi init, write the YAML, and just do Drasi apply -f, just like you do kubectl apply, etc., right, with Kubernetes YAML files. Any questions so far? Yeah, go ahead.
Yeah, I was supposed to ask like if it's only if you can only use Rust, but like you answered that question. But like I wanted to ask like for the GSOC specific proposals, which sector of like the entire pipeline you would like us to like pay more focus or like maybe research more before proposing or like what would be like the standard approximate expectations from us to contribute and like what like in the entire pipeline as a GSOC contributor, like open source contributor, which part of the thing that we are supposed to contribute?
Yeah, so right now there's like multiple repos, right? So I would say the easiest would probably be the Drasi platform, but let me just get back to you on that on the Discord as well. But for now, if you've asked me that question, my answer would be to just go ahead with Drasi platform. The reason being, this runs on top of Kubernetes, and that's where you would find the easiest to also run Dapper alongside Drasi, right? So you can basically do Dapper in it once. So let's just you start with creating your Kubernetes cluster, for which you could use Kind or K3D or whatever, right? Now, once your Kubernetes cluster is running, let's say locally on your system, on Docker, right? So then what you can do is just say Dapper init, and that'll basically initialize Dapper for you, right? And then you can also do Drasi init. So that'll basically install Drasi also onto your existing Kubernetes cluster. Now, the only caveat there is that because the Drasi platform is running on Kubernetes, you have multiple different services, like sources are their own microservices, reactions are their own microservices. So the only caveat there is the debugging kind of becomes a slightly more difficult, right? It's more involved. So you need to look at logs of different components and stitch it together to find out what's happening where, right? What's going wrong if something does go wrong. So that's the only tricky part. But other than that, I think for integrating with Dapper, the easiest way would be to go ahead with Drasi for Kubernetes,
Okay,
which is basically because of the history of the project, it's still called Drasi Platform Repo.
I see. Wait, I have like a follow-up question. Is there like Python SDK for Drasi, or it's like only reactions?
So we have a Python SDK for the reaction. So if let's say the project involves changing something in the core engine, so that's where you would probably need to change something in Rust. So that will be Rust code. But if let's say you're building a new reaction, so there you could just use the Python SDK, right, to build the new reaction.
Okay. Yeah.
Or if you're, let's say, if you need some capability that is missing from the Python SDK, so you just need to go and change that. Let's say you just need to fix this Python SDK and just use that.
I see. Yeah, that makes sense.
Okay, so let's move on. So yeah, how it all fits together? Well, yeah, so this is it. Basically, you have the Drasi core repo, which has the core engine, and the Drasi lib, which is adding like a runtime there, which is optional, which is does not matter for Drasi platform, which is separate. But yeah, this is the core engine repo, and this is the platform repo, which is separate, which is the Drasi platform repo for running Drasi on Kubernetes. And there's a separate repo for Drasi server, which allows you to run it as a single standalone process. And finally, you have your own application. If you want to embed Drasi inside it, just use the Drasi core repo. Now let's come to the uh, documentation and tutorials, right? So we have like a bunch of different tutorials for Drasi for Kubernetes. So this should help you get really comfortable with Drasi platform. And I would strongly recommend the Dapper integration one because that will give you like the full feel of how Drasi can integrate with Dapper itself, right? Because the project itself involves Dapper agents, which is another framework built on top of Dapper, right? So maybe you can also look at some of the tutorials for Dapper itself. So what are the concepts in Dapper, like the state stores and workflow and engine, etc. So you can learn about Drasi and then learn about Dapper, and then try to walk through this particular tutorial. That'll give you a lot more information about the Kubernetes-based version of Drasi and how to use that with Dapper. Yeah, and most of our tutorials also support GitHub code spaces. And if you run out of your free credits for that, you can always use a VS Code dev container. So just use the dev container extension in VS Code, and you'll be able to run the same exact environment locally on your own machine. All right, so yeah, this is like some of the things that we are building right now. We are adding like a bunch of different stuff to our server and library. So you'll see a lot of activity in Drasi core repo happening right now because the team is pretty small and we are just focused on like making these new form factors also available. But we haven't like abandoned Drasi platform at all. So that's also continuing to be used and then we can always add and make contributions there. And yeah, so for now, we are just adding, let's say, persistent indexes and faster recovery for the new server and library versions. And then we are also trying to bring the vector store reaction to the new library and server versions because this already exists in the Kubernetes version, which we saw in the RAG demo, right, in the KubeCon in last November. And then we are also trying to bridge the gap between the different connectors that exist because the platform has 15 plus, whereas source server and library have only 6. We are trying to bridge that gap. And then because we are an open source project, we try to respect whatever the community demand is. So whatever issues people file, we try to build new things based on that feedback. So yeah, I think where to get started, just go to GitHub and then fork our repos. Maybe give us a star if you like the project, and then work on your fork, and then create a PR from your fork. So that would be the recommended way. And yeah, so yeah, as the thing says here, the GSOC project involves both Dapper agents and Drasi, so you can take a look at the Dapper tutorials as well. And whenever you create, let's say, a pull request, it needs like your sign off. So effectively, what you need for that is just use the let me just showcase that. So whenever you are doing a git commit, just use this -s flag, right? And then you can add your message or whatever. So this flag will basically add your sign off message to your commit, and that will basically make sure that your DCO check passes. So yeah, that's all I had. And yeah, I can take any more questions or any things that you may want to discuss or ask. And we are, of course, like I think you both have already joined our Discord, so we have this Discord channel. Feel free to post your questions there. I'll try to answer as much as possible, but we also have other team members who will try to answer as many questions as possible. Yeah. Any questions are fair game. So yeah, don't be shy. Any questions are fair game.
So, in specifically in the GSOC project, we are talking about a reaction agent. So, I want to discuss about what you want from that reaction agent. What is it actually doing? Like,
Right. So what I'm planning to do is maybe we can do another office hours to go a bit more deeper
hmm,
into like whatever the existing reactions are. But here's what I'll recommend for now, right? So let's take a look at the platform repo. So this is the Drasi platform repo, right? Now, if you look at the reactions today, so, okay, let me actually walk you through this, right? So if this is the top level folder, this is the root of the project. And then if we go into sources, we'll find the sources. If we go into reactions, we'll find reactions. This is where the query processor lives. So this is where the query container lives. And inside that, there's a bunch of different components. And there's other things, right? So there's control plane, CLI, etc. Now, if your question was about reactions, so let's go into reactions, right? So inside reactions, you have this folder called SDK, where there's three different SDKs available for you to build reactions, right? So if somebody wants to build a new reaction using .NET, they can use the .NET SDK. If somebody wants to use JavaScript, they can use this, or somebody wants to use Python, they can use this. Now, coming back to the reactions folder. So these are the different reactions that are available today. What I'd recommend is take a look at the MCP reaction in particular, and how, like, go through the documents, maybe take a look at, I don't know if we already have a tutorial or some examples with this, but take a look at how this gets used, right? So the MCP reaction in particular is quite interesting. This is, I think Daniel probably built like a demo using this. It was also shown in another YouTube podcast, and I'll link that in the chat and maybe post it on the Discord server as well. So take a look at how the MCP server is getting used there. The MCP server basically is used there to build like a Python-based game, like a Pac-Man kind of game or like a Terminator kind of game. So just take a look at that. That'll give you some ideas on how the queries can be used, not just for, let's say, building a dashboard, but also for a wide number of different other scenarios, right? Now, coming to Dapper specifically, Dapper agents specifically, I think the goal of the project there is that the Dapper agent themselves, right? So that they are basically built on the concept of Dapper actors, right? So these are basically virtual actors which are not always backed by a live thread. So whenever some logic needs to get executed, the state gets pulled into memory and the thread gets activated and it processes, then it again goes to sleep. So that's the virtual actor pattern that is underlying the Dapper actor framework, right?
yes.
Now, how does the agent know when the data has changed, right? So either the Dapper agent needs to keep on polling for something, or what can happen is Drasi can provide that context to the Dapper agent. So one simple case could be that I think that's probably like a initial uh, milestone that could be part of the project, right? That could be the easiest way where we can showcase that,
Yes.
hey, something changed, and then based on that, the Drasi query was able to launch a Dapper agent. So that is the simpler thing that can be easily done. And then as a the as a follow-up to that, we can have a more involved reaction, which we can talk about in the in our next office hour.
Like today evening hour or next, like,
Uh, so the next iteration of the same office hour, I'll just cover the same material so that people
yes.
in different time zone can catch up the same material. But I'll post another one so we can go over a bit more in more a bit more detail. But in the meantime, what I'd recommend is just go over the one or two tutorials from Dapper website itself to learn about their project, because this project is going to span across two different open source projects, right? So one
Yes.
is Drasi platform, the other is Dapper agents specifically. So let's take a look at the website. So
Actually,
Dapper, sorry, go ahead. Yeah, go ahead. Then.
yeah, actually, you suggested the first like this, that will tell the depper agent what, like there is an issue that's also come to my mind, but I think it is a hard. So there might be many more things because currently we are only providing like there is some Kubernetes issues like we have some like issue and it provides the depper to correct it, but just I think there are much more than this. So just ask.
Yeah, yeah. So you are right. So there's like this would be just the easiest first stepping
Yes.
stone towards the eventual reaction, right?
Hmm.
So this one could be to just let's say launch an Dapper agent.
Hmm.
So you can go to the Dapper website, learn about like how their stuff works, maybe try some quick start or something.
Hmm.
Like what are Dapper agents? How do we
Actually, can you pinpoint few things in Dapper because I think Dapper is quite big and we cannot cover anything.
yeah,
Like,
makes sense. So what I would suggest is, so within Dapper, before going to the agents itself, right? First,
hmm.
maybe try to get a brief, at least a high-level understanding of Dapper
Yes.
itself. So initially, Dapper agents did not exist.
Hmm.
Dapper itself was just built initially for building microservices on top of Kubernetes, right? So it has like a bunch of different common stuff that people might use when building microservices on top of Kubernetes. So it has, let's say, let's take a look at their core concepts. So they have like building blocks, right? So these are the main building blocks. So they have like service invocation, pub sub, because like a lot of people might keep might want to change. Let's say their project started with using Redis streams, but later they want to use Kafka or some other RabbitMQ or whatever, right? So what Dapper does is it basically provides you with abstraction. So you can just write your code using Dapper PubSub, and then underneath you can swap out the actual PubSub layer, right? So that's what
Hmm.
Dapper provides you with. So just go through this like building blocks, and that'll give you some information about the capabilities that Dapper offers. And you'll see if you start looking at the Drasi platform repo, the Drasi platform itself internally also uses Dapper. So whenever
Yes.
you do Drasi in it, you'll see in the logs that it's basically installing Dapper as a precursor. So it's a prerequisite, because internally, whenever sources are calling the query engine or vice versa, or let's say whenever the query engine has processed something, it's sending that results to the reaction. Internally, it's also using Dapper PubSub or Dapper service invocation. So Dapper is really the underlying core layer. So it would be good to know about at least the high level concepts of Dapper. Now, within Dapper concepts, one of the key ones is actors, right? So this is basically allowing us to encapsulate code in a reusable object, and then it basically is it can be scheduled to either get activated after a certain period of time, or it can be scheduled to run on some kind of event. And that's what the that is also fundamental towards the Dapper agents framework, I believe. And once you have like the high level understanding of the Dapper concepts, then I would say that then just go to Dapper agents website, which is this, and try to do their getting started tutorial, right? See what they have to offer in terms of like running your first agent, Dapper agents. What do they do? Like, why did they even build this? What are the core concepts there? What are their core patterns, right? And that will basically reveal a lot more to you, like what's actually missing there and what are we trying to add.
Yes. Thank you. Yes, ma'am.
So don't worry about the second instance of this exact same office hour, because there I'll just try to repeat the same information. And if there's some questions, I'll just answer those. Because that might be like too late or too early for you, depending on your time zones. So the reason why I had these two instances of the same exact office hours is to cover a larger number of geographical zones. But we will also try to have another set of our office hours to go into more details into like what the project is all about. So let's do a GSOC specific one then. That'll give you more clarity.
Okay.
Okay. Any other questions?
No, sir. First, I have mostly the tool how this tutorial you suggested in Darchi, and like I want to go through the Depper also. So the missing part can be filled. Yes. If I have question, I might drop in the evening session again.
Sure.
Otherwise,
Cool. All right. We are at time then. Thank you both for joining. It was good to have you here and great to see your interest in our project. Yeah, and welcome to Drasi. And please feel
thank
free to
you.
post your questions or concerns in Discord.
Thank you.
Thank you.